Okay, so next step there to look at is a singleton. What is it, and how do you write code to create a singleton? So a singleton is known as a design pattern. So just a suggested way to do something. That's what a design pattern is. And it ensures that you can only ever have one single instance of that class, so that you can't create two instances. So there's a certain code that you have to write to make sure that you can only have one single instance. So the example that I have here is a booking system. So there has to be such a way that only one instance, you can only create this instance once. There's no way to create two of them. For an example, a booking system might have its own collection of seats, and say in this booking system there were 100 seats available to book, but if you created two instances of it, now you've got duplicate seats, and some might be booked in the first instance and not in the second, and it could just be a nightmare. So there are 3 steps here to make sure that you can only create one instance of this class. So step 1, have a variable or member variable that will reference the one instance that is created. You don't have to call it instance, but you know, what better name. Make it static. So static means only one per class, so that's a good start. Final means that once it has been assigned a value, it can't be reassigned. So here we have private, so it's only accessible in the class that it's in. It can't be accessed externally. Static, only one of them. Final, booking system. You see there, it's the same data type as the class as well. Give it a name, instance, as good as name as any. The capital letter signifies that it's constant. Equals new booking system. So just a little refresher on static. As soon as this class gets mentioned, and I will be mentioning it in main down here, as soon as the class is mentioned, anything that's static will get set up in memory. So as soon as I mention the class, anything that's static gets set up in memory. The Java virtual machine will come in and create a new instance of this class. And now, back on to step 2, you need to have a public method that will give you access to that one member variable. So a public method, and normally it's called, or can be called, getInstance. In the local dates and local time, there's a method called now, and there's another method called of that will allow you to create an instance. So it might be called getInstance, it might be called of, it might be called now, really only relates to dates and time. So have a public static method. Static, so that you don't need an instance of the class to access that method. You access it directly, class name dot method name. So class name dot method name. You can see this what I have down there in main. Class name dot method name. So booking system dot get instance. So that returns a reference to the member variable. The member variable is a reference to an instance of this class. And that's kind of it, but one more thing just to make sure that you can't create instances outside the class is to make the constructor private. If the constructor is private, there's no way outside of the class of saying booking system equals new booking system. So that is it. I don't know why I have a printout of hello there, just making sure that it works. So
sorry, so just so I'm clear on this, but basically the design patterns, they aren't like a specific thing that's inherent to Java. It's just, here's a way of writing code such to achieve a specific like set of
rules, yeah.
Set of rules. Okay.
Yeah.
That's easy enough to
understand. Yeah, yes, that's it. So a private member variable, have it static and final. You might see, I suppose, in some cases that it's not static, and the final is just a safeguard to make sure inside the code that's here, because it's private, inside this class, that you don't accidentally reassign another instance. So that's why it's final. But maybe, you know, it might not be final once you're making sure that the other code doesn't create another instance of it. Static is making sure there's only one. I think you might see code where it mightn't be static, but then what you need to do is you might need to say if instance is not equals null. If it's not null, then return the instance. If it is null, then create one and return it. So the book you might look at, it does have a little bit more complicated code. I've taken that out and just gone down to the very basics. Have a private member variable, a public method that returns a reference that returns the private member variable. The private member variable makes sure that it has been initialized once and once only. And by making it static, we'll make sure there's only one of them. And make sure the constructor is private so that outside of the class, you can't instantiate it. So booking system bx equals new booking system. So that would normally create an instance of a class, but the constructor is not visible because it's private. So the only way to create an instance of the class is booking system dot get instance. So there are lots of classes like that in the API. If you want to access the console window, I think it's console dot, oh no, see, I'll make a little mess of this now. So system dot, oops. Now, note that I've recorded this and I probably won't get this right. System dot. No, scratch this. I'm trying to take something from my memory from years ago and it's not working at the minute. So but they're the three rules. Private member variable, a public method that will return you an instance, and the constructor private. Is that okay?
Yeah.
Yeah, just hold on this for a quick second.
Yeah, no problem at all.
Actually, I'll just take a photo of it. So there we go. Thank you.
Okay.
That's it. Yeah.
Is that all right, Chris?
Yeah.
So what the book goes into as well, since singleton patterns, since it was created, enums have come along. So I have a second example here of the example that they give in the book basically is how do you make sure you only get one instance of a class or an enum? So this is a bit bizarre. But see here, enum, and I call it booking system 2. Look at that instance. So before we had our cup size small, medium, large. So this is equivalent to just one of the values. So, small, but it's called instant. There can only ever be one instance of an enum constant because they're created in such a way that you only ever access that instance that's there. So they're almost like values within an enum are kind of implicitly static and final, so there only ever is one instance of it. And to use the enum, just down here, booking system 2.instance.
So just to clarify something, instance in this case isn't a keyword, it's just the name of our instance of booking system.
Exactly, it's just a variable name.
And it's in caps because it's a, what you call it? I'll get this. Because it's a sorry, just say it. I can't think of the word.
Because it's constant.
Constant. It's a constant.
Yeah.
Thank you.
So it signifies that it is constant, which means that it is final, can't be reassigned. It's static as well, and the static here, it just means that only one of them can exist in memory.
Sandra, at that time, it's using the booking system 1, that instance.
Booking system, what do you mean by that?
When you create the first class, it will work without the previous example.
The first example here?
Yeah.
Oh, the two are completely separate, yeah.
Oh, okay.
Yeah.
Okay.
Completely separate examples. So this booking system, because it's a class with methods and member variables, you need to call get instance. That's the only public method that's accessible from outside of the class. And an enum, dot instance. So this is, booking system 2. So this is a separate. It's not the same class as the other one, so it's a separate there. It's an enum here.
Could you repeat what exactly do instance in that case?
In this case, it just means a declaration of a value Like before, maybe cup size dot small or cup size dot medium. So you're just, what else could I say? It's declaring one of that type. So that's a declaration of instance. If I try declare another one, for example, if I copy and paste this line, so if I call that booking system 1 and this booking system 2, they're both accessing this one instance. So there's only one variable called instance that exists once in memory. If I have a second reference to instance, it's the exact same instance that was created on the previous line. So how else would I say this? Let me see. I'll just make the code work there.
I try to place that in my mind, how it's related to enums.
Okay. It's just with hang on, if I type this there for a second. Now I don't have a bank account there in the background, so it's that's why it doesn't compile. So if I had a reference to a bank account, if I have a second reference, basically the second reference references the same object or the same instance. So in this case, B1 and B2 both reference the one object.
Yeah.
In the example here, booking system 1, booking system 2, the two separate references, and they both access the same object or same instance, the same variable. Only one of those exists in memory. Because in the background, that is static. In the background, that is final. So there's only one of them that exists and it can't be reassigned.
But as a enum, you can pass another value. So it's hard to explain. Like you said with the cup size, small, large, big. Really, for an enum, it will be, in a case, it will be instance, yeah?
Yeah, in enum, it is an instance. So if I go back to the cup size here for a second, so say cup size small, medium, and large. If I create instances of cup size and I choose small, medium, or large, that's small. There's only one copy of that in memory, if you get me. So if I'm in main and I say cup size one, cup size, we'll just call it C1 equals cup size dot small. So that has created like a reference C1 and it is small. That small only exists once in memory. If I create a second cup size and I also say that it's small, they're both sharing, or the C1 and C2 both access the exact same instance of cup size.
Okay.
So small only exists once in memory. And C1 references that one instance. C2 also references that one small instance. So small only exists once in memory. Not like if I create bank accounts for every single one of us, there will be 3 bank accounts. If I say we're all having a small cup of coffee, I'm afraid we're all sharing the same one. You can only create one small cup size. You can only create one small coffee, like if you get it that way.
Then could you come back to the yeah, that one. Then can be another, I know it's instance, but I try. In my mind, it's small, medium, large. Can you put something like this here?
Let me just put something else in here. I'll put a comma there. So
yeah.
So same kind of semicolon there because there's more code after it. So same kind of idea. There's only one instance of small in memory. There only can ever be one. And there's only one, I know it's called instance. There's only a single one of those either.
Okay.
So one of each. And if I look like I'm creating multiple instances of each one, I'm not. I have 2 references to the same area of memory.
Yeah, okay.
To the same area of memory. So this instance exists only once in the exact in obviously an area of memory. And if I look like I'm creating two of them, I'm not. I'm creating two separate references to the exact same area of memory.
Okay.
Do you see? So, you know, get number of available seats returns 15. If I've booking system 1, booking system 2, booking system 3, I'm afraid they will all return the available seats as 15 because they're all accessing the exact same area of memory.
So if we had a question, like sometimes you'll get questions like how many objects were created.
Yeah,
it's just going to be one.
Exactly.
Like if that comes up, yeah.
Yeah.
Okay.
So if I just
and if you will create the method which return that available seats, and if somebody book one seat, it will for each reference it will show that it's not 15, only 14 at the moment.
correct, exactly. Yeah.
Okay,
yeah.
that's the point. Okay.
Yeah.
Thanks.
So yeah, I just saying there, if I have booking system 1, booking system 2, booking system 3, they're all going to access the exact same one single object. And as you said, if number of seats, if I have a method in here to take one off of that, and I use my 2, 3 references, they'll all have reduced by 1 seat. Yeah. You see?
And it's the situation when, for example, I have access to booking system and you have access to booking system.
Same one.
You buy one ticket and in a system change the amount of tickets. When you book another one, I see that another is sold. Yeah.
Exactly. Yeah. Yeah.
And avoid the situation that we book exactly the same seat.
Yeah. Yeah. Well, to do exactly as you're talking about, you need to introduce threads to make sure that you're not accessing the same method at the same time that I am, that's reducing the number of seats. So if I've called a method to reduce the number of seats, it needs to be locked and no other code can get in there. So that's achieved with threads.
For the time when you finish your thread, yeah?
Yeah, when my thread is finished in that one method, then your thread will be notified that the method's free, and then you can go in and reduce the number of seats.
And this is those lockers, yeah?
Locked, yeah, methods can get locked while one thread is accessing a method. It will be locked from other threads, and then when the method is finished, the lock will be released, and then other code as in other threads can go and access that method.
Okay, thank you.
So that's later in the book. Okay, is that all right on the singletons?
Yeah. It will be on the Dropbox, yeah?
Yeah, all this I have saved on Dropbox, yeah.
Cool, yeah, fine, thank you.
Now, so that's our singletons. I said there's one other more complicated example in the book, but I'll get you to look over that yourselves. And anyway, by reading the book, it'll be a refresher, and hopefully it can make a little bit more sense there as well. Okay, I'm gonna stop recording there because that's finished.